Okay. I don't have the question. You have to get out the question, open the phone or the laptop. I'm recording. Okay.
Oh. Can you see? No.
Yeah, okay. Should we start with the introduction?
No.
Okay.
It's not the issue.
Okay. Hello. I'm an
You're
engineer.
an engineer.
I'm not. Okay, so today we're gonna solve problem 9, which is about percentage increase. So a bank pays an initial capital of 1,000 euros deposited in an account with an annual interest rate of 3%. So we have to compute the capital after a year if the interest are put on an account in a yearly, every 6 months, daily, or every instant in a continuous way basis. So I'm gonna start with the first one. So we have 1,000 euros deposited in an account, and in a year, it's gonna increase for 1 point, and it's the percentage of increase is 3% in a year. So in a year, it's gonna increase for this much. Yes. So, which is 1,030 euros. Is it euros like this? Like this? Like this? I'm not sure. No, it's not like that. It's like this. No. Okay. Euros. This much euros. Okay. So Asad is gonna solve the second part. Here you go. You can take the calculator. You can take the
Well, second one is
every 6 months.
compute the capital of the year if the interests are put on the account every 6 months. Right. So when we say every 6 months, it means that it's a half a year, right? So we're gonna write like this: 1 plus. So this is just percentage increase. So 1 plus 1 over 2 half a year multiplied by 3% increase, which is like 0.03 over 100. Okay, this is 6 months. This is for 6 months, and then we multiply this by other 6 months. And then the initial value, which was 1,000. Okay. And this is for 6 months. And we calculate this. Okay. So 1 plus 1 over 0.5 multiplied by 0.03, and this is basically squared. Okay. So, and then this multiplied by 1,000. Okay, basically this is 1,000 1,030. No, it's not. It's 1,030 and 25 cents.
Okay.
Now I'm about to continue.
Yes. So now we gotta solve for the daily basis, which means that, for example, if in 6 months this is what happens, the increase, and then we multiply it by 1 more, and we get in a year, in if it increases every day, in a year the increase will be 1 plus. We divide by the number of days in a year, multiplied by percent, raised to the power of days, and multiplied by 1,000 years. Or if we have 366 days in a year, which can be the case, then it's gonna be 366 to 3% and raised to the power 366 and multiplied by 1,000. And it is gonna be roughly the same number as others because the percentage of increase is not that high, and 3,030 euros and 46 cents. Which this one is gonna be. Okay, let's calculate it. 1 plus. Okay, so it's gonna be the same thing. It's gonna be roughly the same as the one above. Yes. Isn't the case? Yes. And now Asad's gonna compute the last one. You can do it this one.
This one was almost the same. This wasn't cents. Okay. The fourth one says at every instant in a continuous way. So basically, when we say continuous, we are referring to limits, as always. So it's gonna be a limit at every instant means let's take n, some n, as we took here daily, so days every 6 months, and then it was a year. And limit as n approaches infinity of 1 plus 1 over n, right, multiplied by 3 over 100 or 0.03 raised to the power of n. Okay. This is the way how we calculate for every instant in a continuous way. But we should recall the formula. There's a formula for calculating this limit. Yes. So there was a formula, if you remember, but shape right. I need to multiply by 1,000. Okay. I was going to add this.
Okay, we
So,
got it, we got it.
A limit as n approaches infinity of 1 plus 1 over n raised to the power n, right? It was e. Yes, I remember this. And but what if we have, let's say, instead of 1, 2, then it's gonna be e to the second power, or e squared. This is the Euler's number, by the way, which is equal to 2.7. There is a general formula for this. Limit as n approaches infinity of 1 plus, let's take x over n raised to the power n, and is equal to e to the power x. So now, since we know this formula, we can use it here. So let me erase this part. I will keep the giant one for let's see. Okay. This is in this case, this is 1 over n, so our x is what? 3 divided by 1,000 multiplied by 1, which is 3 divided by 1000. And this basically gives us e to the power of, this is our x, right? So this is x over n. And if it's x, then it's going to be e to the power of 3 over 100, or 0.03. And multiply this by 1000. And in order to calculate this, we need a calculator, of course. E, well, what is it? Okay. Be my assistant this time.
Assistant? Seriously? We are colleagues. I'm not an assistant.
Okay, sorry. Let's check.
Not to the camera. Don't say such things.
Okay.
Here's yours.
Sorry, calculators, so she knows better than me how to use it. 1030.45434. I want it to be precise. This is precise.
Oh, precise?
Yeah.
Well, I think no.
No.
I would say no. It's like, it's cut in parts.
It's an amazing calculator.
I mean, it's not. It's not a
Anyway,
scientific one. It's
I
just
wanted
very
to be an engineer here. I want to be precise in my calculation. Well, and of course this is in years, right? Not in dollars, in years. And that's it.
Okay.
Thank you.